Welcome to this class. Today I am continuing the chapter Simple Machine of Unit 8 of the subject Science and Technology of Class 9. This is last part of this chapter, and in this chapter I am going to focus on weighs and screw. But before starting this weighs and screw, I want to recall something which was taught in previous class. They are what? Types of simple machine. We know that there are four basic types of simple machine: lever, pulley, wheel and axle, and inclined plane. And all these are taught in previous class, but today we are talking about the weighs and screw, which are considered to be the changed version of inclined plane. Actually, weighs and screw are inclined plane. They are changed version, or we can say that modified version of inclined plane. Okay, before entering into the weighs and screw, I want to show you some weighs and screw which we commonly use in our daily life. Look at this. This is hukuri, and this is the identity of Nepal also. We know this, and it is used in different purpose in different sectors. And here we have karda. This karda is a small weighs, this is a little bigger weighs, and these two are weighs, but here we have chakmak, and chakmak is not the weighs. It is used to make the hukuri sharp if it becomes blunt, like this. Now, this is another weighs. It is used in kitchen to cut vegetables, and this is called chuleshi. And this is knife, we know about this. These are the weighs. All these are wedges. Have you noticed this? It has sharp edge and its thickness increases up to the another end. But I want to show this also. This is a screw. This screw has got thread on its surface, and it is used to connect two objects tightly together. And sometimes a screw is present in this pen also. Look at this. We have threads on the cylinder of this pen, this marker pen, and when we insert here and we rotate it, then two objects are tightly comes in contact with each other. This way, so these two are what? Screw, and these are wedges. Okay, now I want to define weighs. What is weighs? Weighs can be defined this way. Weighs is a simple machine which consists of a sharp edge, but its thickness gradually increases up to the another end, and it works on the principle of inclined plane. We have to take care about this. Actually, weighs is the changed version of inclined plane. That's why its principle is inclined plane. It works on the principle of inclined plane, which was taught in previous class. Now I want to show some diagram of this weighs. Look at this is axe, this knife, this saw which is used in making furniture, this pencil sharpener which you use in everyday class, and this is trowel. Trowel, you may be confused about this trowel. Trowel is a lever, but when its edge is used to insert into the soil, or it is inserted into the sand, or it is inserted into the ice or snow, then it works as this weighs. Otherwise, this is actually lever, and the trowel becomes a lever when it is used to throw this soil or sand or ice to a certain place. And its edge is sharp when it is inserted into the soil, then it works as this weighs. Okay, this is jeeper. Jeeper is another weighs. Now, I want to show this again. Look at this. We have to remember all these very carefully. Look at the diagram also. This is axe, and this knife, and this is kukuri, and this is chuleshi, and this is what? Saw, and it has sharp teeth here, and here jeeper, and another one is trowel. And these are the common ways which we use in our daily life in different purpose. Okay. Now it's time to know about their use. For what purpose actually this weighs is used? Weighs is used in different purpose. I want to show you with animated or video clip, animated diagram or video clip. Look at this video clip. A man is splitting up a log of wood into two pieces, and an axe is used for it. And another person is using kukuri to make one of the end of the log of wood sharp. And another person is cutting this lemon into two pieces using a knife. This is very interesting. A person is using sword to cut water lemon. Now looking at all these, you can understand easily that either the wedge is used to cut an object into different pieces, or it is used to split up the substances. That's why we can say that there are two major uses of wedge. One is it is used to cut or split up different substances. Another major use is it is used to increase the distance between heavy objects. The second point may be a little confusing for you. I want to describe this. It is used to increase the distance between heavy objects. If we have two very heavy objects and there is very little gap in between them, then a wooden wedge can be inserted into that gap, and if we apply force, then the gap can be increased. And other instrument can be inserted between that gap, and so they can be separated easily. It is used in marble mines. To get the slab of marble very carefully without any break, we can use wooden wedge to increase the distance between two marble pieces. Okay, now after this, it's better to have a diagram of wedge. If you are told to draw diagram of wedge, you can draw this way. Look at this. Wedge is represented like this, and here we apply effort, and the applied effort converts to strong separating force. The applied effort converts to strong separating force. It will be better to have object also. Look at this is inserted into the object, and we are going to cut this object, or we are going to split up this object into two pieces. Let's say this is the object. Then this is the maximum height. This is the maximum height of the wedge inserted into the object. This is the maximum height, can be represented by h, and this is the maximum thickness of the wedge inserted into the object, that can be represented by the symbol L. It is given in your book L, that's why I am writing L. This maximum height inserted into the object, this maximum thickness inserted into the object. This is the representation of the diagram of wedge. Okay, now looking at the diagram, I think you are clear that this maximum height of the wedge inserted into the object can be considered as effort distance, but the maximum thickness of the wedge inserted into the object can be taken as load distance. This is effort distance, this is load distance. That's why what can I write? Velocity ratio is equal to effort distance upon load distance. We know this. It was taught in previous class also, and effort distance in this case is h, maximum height of the wedge inserted into the object, and load distance is here L, the maximum thickness of the wedge inserted into the object. That's why in case of this wedge, we can write velocity ratio symbolically this way. The formula for the velocity ratio is h by L. Now I want to define the velocity ratio. Now let's start. Velocity ratio can be defined this way: the ratio of the maximum height to the maximum thickness of the wedge inserted into the object is called velocity ratio of the wedge, and its formula can be written as velocity ratio Vr is equal to height of the wedge denoted by h and thickness of the wedge denoted by L. Okay, now looking at this all, now what sort of advantages can be taken from this wedge? Now I want to talk about the advantages of the wedge as simple machine. Now, these are the advantages of the simple machine. A simple machine magnifies the effort. Another, it changes the direction of force. Another one, it increases the speed of the work. There are three major advantages of simple machine. Either it magnifies the effort, or it changes the direction of the force, or it increases the speed of the work. If one of these advantages can be taken from a tool or device, then that is called simple machine. Now we are going to match this with ways. From ways, what advantage of simple machine can be obtained? Look at this is ways, and this is the maximum height of the ways, and this is the thickness of the ways. And now looking at this diagram, we are clear that height is greater than is thickness. Height is taken as effort distance and thickness is taken as load distance. That's why effort distance is always greater than load distance. If effort distance is greater than load distance in any simple machine, then that simple machine magnifies the effort. It means ways magnifies the effort. This advantage can be taken by ways. First advantage. Now what about the second? It changes the direction of force. Does it change the direction of force? Let's take the diagram again. This is the diagram of ways, and here effort is applied and it converts to a strong separating force. Now have you noticed this? Effort is applied in the vertically downward direction, but the same effort is converted into a strong separating force in another direction. That's why we can say that this machine changes the direction of force, because force is applied in downward direction, but now it is acting in angle to cut the object. That's why this simple machine, that is ways, can change the direction of force. Now what about third? It increases the speed of the work. Ways can increase the speed of the work. Let's think about this. To increase the speed of the work, you know that load distance should be greater than effort distance, and it is not possible in ways. Effort distance is always greater than that of the load distance. If effort distance is always greater and load distance never be greater than effort distance, then it cannot increase the speed of the work. That's why I want to remove this. We can get only two advantages of simple machine by this ways. What are they? It magnifies the effort and it changes the direction of force. Okay, now let's talk about the type of ways. Probably not given in your book. It will be better to have idea about the type of ways. Now let's talk about the type of ways. Probably not given in your book, but it will be better to have the idea of type of ways. What is this? This is inclined plane. You are taught in inclined plane. And this is the length of the inclined plane, which is considered as effort distance, and this is the height of the inclined plane, which is considered as load distance, and this is the base of inclined plane. If I turn this inclined plane like this, now this is no more inclined plane. Now it appears as ways. One edge is very thin, and as we go to another end, its thickness gradually increases. And this is actually modified version of inclined plane. I mean to say, ways is modified version of inclined plane, or we can say that it is changed version of inclined plane. And this is called single ways. Now, if the identical ways is attached with it, like this is the ways, same ways, and if another piece which is identical to the previous and their base are attached with each other like this is the base, and if their base are attached with this, now we have another ways. This is called double ways. This way we can say that ways is of two types. One is single ways, another is double ways. Both of them have same principle. Both of them works on the principle of inclined plane. Okay, I think we have done lot about this ways. Now it's time to go through numerical problem, because we know what is mechanical advantage, and we have now the velocity ratio of ways. It is different than other simple machine. It is taken as the ratio of maximum height inserted into the object to the maximum thickness inserted into the object. That formula can also be used. Using this formula, we can calculate mechanical advantage, velocity ratio, and efficiency. Let's solve one numerical problem. Look at the numerical problem. Okay, looking at this problem, 450 Newton effort is applied on a log of wood using an X of height 10 centimeter. If it produces 900 Newton separating force and inserts into the log of wood to the depth of 5 centimeter making a gap of 2 centimeter, calculate the following. Have you noticed that height of the wedge is given twice? Total height is given 10 centimeter, but the height inserted into the object is 5 centimeter. This is effort distance. Total height, we don't have to consider total height because the whole height is not inserted into the inclined plane. Now, question is not finished. Now we have to calculate mechanical advantage, velocity ratio, and output work, input work, and efficiency. Now, how to solve this numerical problem? Now, I want to go to board to solve this numerical problem. Okay, effort is given. Effort is equal to 450 Newton. Now, another information, 10 centimeter height we are not taking because this is total height not inserted into the object. So, it produces 900 Newton separating force. It means load is 900 Newton is given. And separative force inserts into the log of wood to the depth of 5 centimeter. It inserts into the wood or something to 5 centimeter. It means effort distance that can also be written as H. H is equal to 5 centimeter. But the gap is 2 centimeter. It means load distance, or we can say L, is equal to 2 centimeter. These are the information given. 4 informations are given and 5 are the questions. It's very interesting. Let's go through the solution. Mechanical advantage. First question is mechanical advantage. Now, MA is equal to what? We have formula MA is equal to load by effort, and this is equal to load is 900 Newton and effort is 450 Newton, and if we divide then we'll get 45 2s are 90, 45 1s are 45 2s are. Therefore, mechanical advantage is equal to what? 2. What it mean? Effort is magnified by twice. Effort is 2 times magnified. Now second is velocity ratio. Now question is velocity ratio is equal to what? Now we have formula velocity ratio is equal to effort distance by load distance. We can write H by L here, and height is 5 centimeter and L thickness is 2 centimeter. If we cut this centimeter, divide 5 divided by 2 gives velocity ratio is equal to 2.5. It means effort covers 2.5 times longer distance than that of the load. Now, let's go through other also. Next question is output work. Third is, we can say work output symbiotically. Work output is equal to question mark. Now, work output, do you remember this? The work done by the machine is called work output, and work done by the machine is calculated by using this formula, work output equal to load into load distance. It is the product of load and load distance. That's why load is given 900 Newton and load distance is here. Load distance is 2 centimeter. That's why I'm writing 2 centimeter. But centimeter doesn't work because work is calculated in joule. Joule is the unit of work according to SI system. That's why we have to convert this into meter to get joule. So I'm writing differently. 900 Newton into 2, if divided by 100 then it comes in meter, and this is equal to 900 Newton into 0.02 meter, and this is equal to 9 2s are 18, 2 zeros point is there, that's why Newton meter becomes joule, 18 joule. Therefore, work output is equal to 18 joule. Yes, this work output is calculated. Now we have to go through work input also. Work input, Wi, can represent work input. Work input is equal to what? Effort times effort distance. We know effort times effort distance, because the product of effort and effort distance is work input. Work done on the machine is called work input. And effort is given 450 Newton, and effort distance is given as 5 centimeter, and that's why 5 centimeter, and this is equal to 450 Newton. If this 5 centimeter is divided by 100, then it comes in meter, and directly I am writing 0.05 meter, because we have to get the result in joule. Newton meter gives joule, so I have to multiply now. 5 5s are 25, gives 5, and 5 4s are 20, and carry over 2 is 22, then point is there, that's why 22.5 joule. You can use calculator also. Therefore, work input is equal to 22.5 joule. Work input is always greater than work output, because a little amount of work done is wasted due to the friction, and that's why output work is always less than input work. Now we have to calculate efficiency. Now I'm going to calculate efficiency here. Efficiency is denoted by eta. Eta is equal to what? We can use one of the formula among efficiency is equal to MA by VR into 100%, or efficiency equal to work output by work input into 100%. Both are present here, but I am using just simple one, just MA by VR. MA by VR into 100%. Now mechanical advantage is 2, velocity ratio is 2.5, and we have to multiply it with 100%. Now 25 4s are, but here we have point, that's why we can write here 0. You can use calculator. Now eta is equal to 40 2s are 80%. This way we can solve the numerical problem related to the weights. Okay, after all this information, now it will be better to have a question. Yes, so I want to give you a question, and think about this question and try to get the answer. Okay, the statement, I made a statement, weights is one of the another form of inclined plane which helps us to increase the speed of the work. Is it correct? You have to think about this. Okay, keep on thinking. Argument 1, weights magnifies the effort, so mechanical advantage is always greater than velocity ratio in this simple machine. Is it correct? Now another argument, thickness of weights is always less than its height, so velocity ratio is always greater than 1 in this simple machine. Looking at all these, you have to select one of the option among these 4. Which one is correct? Now let's start with option number 1. Only statement is correct. Check it out. Statement is given, weights is one of the another form of inclined plane. Yes, which helps us to increase the speed of the work. This part is wrong. This part is incorrect. It never increases the speed of the work, because to increase the speed of the work, load distance should be greater than effort distance, but in case of weights, effort distance is always greater than load distance. That's why statement is incorrect. So I want to drop this option number 1. This is incorrect. Now look at 2. Only argument 1 is correct. Is it so? Now argument 1, weights magnifies the effort. Yes. So mechanical advantage is always greater than velocity ratio in this simple machine. The second part is not correct, because in every simple machine, velocity ratio is always greater than mechanical advantage, because velocity ratio is the ratio of two distances which is not affected by the friction, but mechanical advantage is the ratio of two forces, and this is affected by this mechanical advantage is affected by friction. It is always less than velocity ratio. That's why argument 1 is incorrect. So I'm going to cancel this second one also. Now look at third. Only argument 2 is correct. Looking at this argument, what happens? Let's see. Thickness of weights is always less than its height. Yes. So velocity ratio is always greater than 1 in this simple machine. Yes, this is correct, because thickness is less, load distance is less, and height is effort distance, which is more. Effort distance upon load distance is always greater than 1. That's why this is correct argument. Argument 2 is correct. Only argument 2 is correct. This is the correct answer. But what about 4? Statement and both the arguments are correct. This is not correct. This is incorrect. That's why we are going to tick number 3. This is the correct answer. Correct option. Okay. Now it's turn of a screw. We are starting screw. Screw. What is it? Before the definition of a screw, I want to show you something related to the screw. Look at this. This is paper inclined plane. I made a paper inclined plane, and this is the base of the paper inclined plane, and this is the effort distance or length of the inclined plane, and this is the height of the inclined plane, which can be considered as load distance. Now, if I wrap this on the surface of this cylinder, then what happens? Let's see. And it is done in such a way that the base should be perpendicular to the cylinder, and if we wrap it, then we'll get this type of appearance. I want to show you the appearance. First, let's finish the work. Look at this, very interesting. The length of the inclined plane appears as the thread of the screw on a surface. Thread of the screw. And this is a screw. And we have thread on this screw. In the same way, here we have thread. It means we can consider that a screw is actually made by the inclined plane, and an inclined plane is wrapped around the rod or cylinder to make a screw. So we can define a screw this way. Screw is a simple machine which can be considered as an inclined plane wrapped around a rod or cylinder. For example, screw jack, vise, screw, etc. Okay, now let's see the example with the help of diagram and animated video. This is screw nail. A screw nail is used to connect two objects tightly together. Nail is also used to connect two objects tightly, but a screw produces very tight connection between those two. That's why a screw is used to connect two objects tightly together. This is a screw nail. And this is vise. This vise is used in workshop. In workshop, at one end of the heavy table, it is fixed. And whenever we have to take any object, the metal object, then we'll take that metal object in the grip of this vise and we work on it. We have to sometimes cut the metallic object, or sometimes we have to use file over it, and it is done by taking it in tight grip by using this vise. This is vise. Now next is screw jack. I think you have seen this. This screw jack is used to change the wheel of the vehicle. Now I want to show the screw with its thread very nicely in detail. These are some examples which I gave you, but it will be very good to have very nice idea about the thread of the screw. I want to show it nicely here. These are the screw nails, and looking at this screw nail, if you have noticed, the distance between two neighboring thread is here more than this screw, and it is different in this and this and this and this. The distance between two neighboring threads of the screw is different in different screw, and the distance between two neighboring threads can be seen very nicely here also, and this distance between two neighboring threads of the screw is named as pitch of the screw, and this pitch of the screw is actually load distance of the screw. So now I want to define pitch of the screw. The distance between two neighboring threads of a screw is known as pitch of the screw. Actually, it is load distance in this screw. Now, how to understand this very nicely, I want to show again with the help of the screw. Look at this screw. This screw can be driven by this screwdriver, and when we rotate this, then screw advances in certain object when we rotate this. The distance traveled by the effort in the circular path which I am applying here, the effort, distance traveled by the effort in the circular path can be taken as effort distance, and the distance with which it advances into the object can be taken as load distance. When it takes one rotation, then distance covered by the effort will be circumference of this wheel, and at the same time the distance covered by the load will be the pitch, the distance between two threads. That's why we can define velocity ratio this way. Velocity ratio of a screw can be defined as the ratio of the distance traveled by the effort in the circular path to the pitch of the screw is called the velocity ratio of the screw. And it can be written in the form of formula. Velocity ratio is equal to distance traveled by the effort in the circular path, that can be symbolized as circumference 2 pi r, and divided by pitch of the screw, which is denoted by P. It means twice pi r by P. Now remember again, load and effort distance in the screw. Load distance is pitch of the screw, which is denoted by P, and effort distance is distance covered by the effort in the circular path when the screw is turned once, 2 pi r. Okay, now after all this, what are the advantages of a screw? Let's talk about the advantages of the screw. There are three major advantages of the simple machine which I mentioned previously. Now out of those three, how many advantages can be taken by the screw? Number one, it magnifies the effort. The reason is very simple. Comparatively, effort distance is very long. The distance covered by the effort in the circular path is very long. Effort distance is very long than that of the pitch, which is load distance. That's why effort distance is longer than load distance. It magnifies the effort. Now next, it changes the direction of force also, because we are applying effort in the circular path, but the load is moved towards the horizontal distance this way. We are applying force this way, effort takes this direction, but load takes this direction. It means it changes the direction of the force. But it cannot change the speed of the work, because load distance is always less. Pitch is always less than that of the effort distance. Okay, now it's time to solve a numerical problem related to a screw. Let's go through this numerical problem. This is a screw. A screw having pitch 1 centimeter has negligible friction. Look at this word, negligible friction. Friction is nil. We can consider that it has 100% efficiency because frictionless. It's considered as frictionless. It is rotated by an iron rod, this type of iron rod of length 35 centimeter to raise certain load by the application of 80 Newton effort. Now calculate the load. Now what information are given? I'm going to write this and then we'll go through formula and we'll get the solution. Look at this. Pitch is given. Pitch is denoted by P. This is load distance. This is 1 centimeter. And another information we have, this is length of the rod. It means radius of the circular path of effort. This is the circular path of effort. This is the circular path of effort, and radius of that circular path is given. R is equal to what? 35 centimeter. And any other information? 80 Newton effort is applied. It means effort is given. This is 80 Newton. Now, what is the question? Calculate the load. Load is equal to question mark. Now, looking at this information, we have to think about this. What exactly? Efficiency is 100%. It means it is frictionless. In every simple machine, if it is frictionless, considered to be frictionless, then efficiency is 100% and mechanical advantage is equal to velocity ratio. Mechanical advantage is not affected by the friction. That's why we can use this formula. In this case, mechanical advantage is equal to velocity ratio because it is frictionless. So, mechanical advantage can be written as load by effort, and velocity ratio can be written as what? 2 pi r. distance traveled by the effort is the circumference 2 pi r, r is here, and the pitch is the load distance, velocity ratio is effort distance upon load distance is p. Now here load we have to calculate, and effort is given 80 Newton, and 2 into pi, value of pi is 22 by 7, into radius is given 35 centimeter, and p is also given 1 centimeter. Centimeter cancel, 7 5s are 35, 5 2s are 10. Let's go through left hand side. L is equal to 80 Newton into, now 5 2s are 10, 10 multiplied by 220 5 2s are 10, and 10 multiplied by 22 becomes 220. Now only Newton is left, therefore load is equal to 8 2s are 16, 8 2s are 16, carry over 1, 176, 0, there are 2 0, and Newton, this is the final answer. The load is 17,600 Newton. Now look at this, only 80 Newton effort was applied, but it is magnified to very huge value, 17,600 Newton. That's why we can conclude that screw is one of the simple machine whose magnification is very high in comparison with any other simple machine. Its magnification is very high. Okay, now we finished screw also. Okay, now the class is over. What I taught today, I told you about the ways and what are the advantages of ways, how to make the diagram of ways and numerical problem related to ways and advantages of the ways. In the same way, what is a screw and what is its diagram? Diagrammatically, we can show only the screw nail, but there are different screws, that's why different diagram cannot be made. And how to solve the numerical problem of a screw, what advantages can be taken from the screw, etc. etc. Now this chapter simple machine is finished. In next class we'll meet with some other chapter. Thank you.